The two important branches of astronomy based on the method of study are theoretical astronomy and observational astronomy. These two branches are both interdependent, like all other theoretical and experimental physics. Some of the theoretical predictions leads to introduce new experimental tools. At the same time, some experimental data available will help us to modify the existing theories. So we can say that this both theoretical and observational astronomy are interdependent. So we will look into this theoretical astronomy first. This theoretical astronomy uses the analytical model of physics to describe astronomical objects and astronomical phenomena. The theoretical astronomy is usually assumed to have begun with Johannes Kepler 1571 to 1630 and his laws of planetary motions, or we call it as the Kepler's laws of planetary motion. Theoretical astronomy does not try to predict the position, size and temperature of every star in the heavens, but has concentrated upon analyzing the apparently complex but periodic motion of celestial objects. Theoretical astronomers use wide variety of tools which include the analytical models, example the prototype to approximate behavior of a star, and computational numerical simulations. Theorists endeavor to create theoretical models and figure out the observational consequences of those models. This helps observers look for data that can refute a model or help in choosing between several alternate or conflicting models. The different topics under theoretical astronomy include the stellar dynamics and evolution, which actually discusses the motion of the stars, and the evolution means how the stars are formed and the life cycle of a star or life history of a star. Another topic is the galaxy formation, how the galaxies are formed. Another topic under the theoretical astronomy is the large scale structure of matter in the universe, and another one is the origin of the cosmic rays. The cosmic rays are the high energy radiation mainly originating outside the solar system. And another hot topic in the theoretical astronomy is the general relativity and physical cosmology, including string cosmology and astroparticle physics. So now let's discuss about some of the different astronomical models. This table actually contains the 5 different astronomical models. These are some of the important astronomical models. So let's discuss each one. Here the physical process is the gravitation. As you know, all of you know that gravitation is the attraction between any two massive objects. If anything have a mass, then these two will be attracted according to Newton's law of gravitation. So gravitation is a attractive force, existence of an attractive force, which is the physical process. To discuss or to study that physical process, the experimental tool used is the radio telescope. Radio telescope means the telescope which collects the radio waves coming to Earth or to the atmosphere of Earth from other celestial objects. The theoretical tool used for the studying the physical process gravitation is the self-gravitating system. The theoretical tool is known as the self-gravitating system. self-gravitating body is one that is held together by the gravitational attraction of its constituents. For example, if we consider a star, the different atoms of the stars are held together by the gravitational force. Otherwise, due to the excessive pressure and temperature inside the star will be exhausted fastly. So this has been compensated by the excess pressure and the energy released in the nuclear fusion processes inside the star is counteracted or compensated by the gravitational force between the atoms of the star. And this model tries to explain or predicts the emergence of a stellar system. Emergence of a stellar system means how a stellar system has been formed. Example, how the solar system is formed. The solar system actually consisting of sun as the star, and 8 different planets are revolving around it, and different comets are revolving around the sun, and different asteroids are revolving around the sun. These all things, the sun, the planets, the comets, the asteroids, etc., form the solar system. So it is a stellar system. So how this stellar system has been emerged is explained by using the theoretical tool self-gravitating system. Another physical process is the nuclear fusion process. The experimental tool to study the nuclear fusion is the spectroscopy. Spectroscopy means by analyzing the spectrum, we can determine the energy of the radiation coming from that particular celestial object. The theoretical tool uses the stellar evolution, and it tries to explain how the stars shine and how the metals are formed inside a star. Another physical process is the Big Bang. The experimental tool used for this purpose to study the Big Bang theory is the Hubble Space Telescope. And the theoretical tool is the expanding universe, and it tries to explain or predict the age of the universe. Another recent physical process is the quantum fluctuation. The theoretical tool used for the process explaining the process of quantum fluctuation is the cosmic inflation. Quantum fluctuation means the variations in the energy in different points of the space. So the inflation is the theory of exponential expansion of space in the early universe. This proposed in the early 1980s by Alan Guth. It tries to explain the flatness problem of the universe. Another physical process is the gravitational collapse, and the experimental tool uses the X-ray astronomy, and the theoretical tool is the general relativity. It explains the black holes at the center of the Andromeda galaxy, or it tries to explain the general theory of relativity, tries to explain the existence of the black hole, and how the gravitational collapse means finally what happens when all the energy of a system is released, or the fuel of a star is completely exhausted, then the gravitational force will overcome all other forces, and it will shrink, the object will shrink, and the size of the object will become very small, but its density will become very higher, and that process is called gravitational collapsing. So that most of the stars will become black hole at the end of a gravitational collapse. So these are the different astronomical theoretical models and the different problems which tries to explain the emergence of the stellar system, how a star shines, and how the metals and the heavy elements are formed inside a star, and it predicts the theoretical model expanding universe tries to predict the age of the universe, and how the black holes are formed, etc., are explained by using the different theoretical astronomical models. Now let's come to this observational astronomy. Observational astronomy is a division of astronomy that is concentrated with recording data about the observable universe. It is the practice and study of observing celestial objects with the use of telescopes and other astronomical instruments. As a science, the study of astronomy is somewhat hindered in that direct experiment with the properties of the distant universe are not possible, that you know, because astronomy discusses with the celestial objects and we cannot go there, and we cannot have a experimental setup in the distant objects. So the laboratory for astronomy is the entire universe. So we are not able to reach in every point of the universe. So we can say that the study of astronomy is somewhat hindered in that direct experiment with the properties of distant universe are not possible. However, this is partly compensated by the fact that astronomers have a vast number of visible examples of stellar phenomena that can be examined. This allows observational data to be plotted on graphs and general trends recorded. Galileo Galilei turned a telescope to the heavens at the first time and recorded what he saw. Since that time, the observational astronomy has made steady advances with each improvement in telescope technology. So we can say that observational astronomy has begun with the Galileo Galilei's invention of the telescope. A traditional division of observational astronomy is given by the region of the electromagnetic spectrum observed. You may be heard about the electromagnetic spectrum. So, depending on the observation on the electromagnetic spectrum, we can have different divisions of this observational astronomy. First one is the optical astronomy. It uses optical components like lens, mirrors and solid state detectors to observe. In this division, we observe the light from near infrared to the near UV wavelengths. That means around 400 nanometer to 700 nanometers. So in the optical astronomy, we will observe the region of the electromagnetic spectrum with wavelength 400 nanometers to 700 nanometers. You know, this optical means actually the visible one. That's why we are using the optical components like lens, mirrors, and in the advanced technology we will use some solid state detectors also. Another division is the infrared astronomy. It deals with the detection and analysis of infrared radiation. And you know that the infrared radiation is around 1 micrometer in wavelength. The most common tool is the reflecting telescope, but with a detector sensitive to infrared wavelength. So we are using a reflecting telescope with a detector sensitive to infrared wavelength is used for the observation in the infrared astronomy. Another is the radio astronomy. In this one we observe or detect radiations of millimeter to decameter wavelength. So millimeter to decameter means 1 millimeter to 10 millimeters wavelength. So these are the wavelength of the radio waves. So in the radio astronomy we will observe the radio waves. Another one is the high energy astronomy, which includes the X-ray, observation of the X-rays, observation of the gamma ray, and extreme ultraviolet astronomy. So this is another one, high energy astronomy. High energy means it actually includes the detection and analysis of the high energy radiations like X-ray, gamma ray, and extreme UV. In addition to using electromagnetic radiation, modern astrophysics can also make observations using neutrinos, cosmic rays, or gravitational waves. The different tools used in observational astronomy are telescopes, the photography, blink comparator, the position or crosswire micrometers, spectrograph, photoelectric, photometry, etc. So these are the different observational tools or instruments used for in the observational astronomy. That is the telescopes. Telescopes are different types of telescopes. The photography and astrophotography is one of the interesting amateur techniques. So nowadays the amateur astronomers are using astrophotography. The blink comparator, the position or crosswire micrometers, the spectrograph, and photoelectric photometry are the different tools used in the observational astronomy. Okay, now we will discuss about the amateur observational astronomy, because our curriculum is designed for the amateur observations. So astronomy will have two branches, the theoretical astronomy and observational astronomy. What are the different topics which comes under the theoretical astronomy are already discussed, and how the observational astronomy, or what are the different branches or divisions of the observational astronomy are also discussed. Now we will come to the amateur observing. What do you mean by amateur and amateur observing, and what are the different tools used for these amateur observations, etc. will be discussed in the next lecture. Thank you.